All right, let's dive right into this explainer and look at how the US Treasury is fundamentally rewiring Wall Street's cybersecurity today. For years, the whole conversation around quantum computing and the threat it poses to our digital security has been treated like some sci-fi movie, like it's just something for future generations to worry about. But as we're going to see from some really fascinating recent analysis by the Center for Cyber Diplomacy and International Security, that waiting period is officially over. We are literally moving from a theoretical warning straight into the operational architecture of the global financial system. So let's start off by posing this big question to you. When exactly will quantum computers break our encryption? It's the question everyone always asks, right? But we need to completely shatter the illusion that this is a problem for the distant future. Now, it's totally true that a cryptographically relevant quantum computer, a machine actually capable of breaking modern public key cryptography, isn't publicly known to exist today. But focusing solely on when someone finally builds that machine completely misses the actual timeline of the threat we're facing. And this is why. The strategy of harvest now, decrypt later absolutely proves that our security timeline begins long before the actual quantum computer even exists. What this means is your data is at risk right now. Adversaries can just hoover up sensitive, encrypted information today and sit on it. Then, once quantum technology matures, boom, they decrypt it. So if your data needs to stay confidential for years to come, we're talking national security secrets, highly proprietary financial algorithms, or even just your long-term personal data, the relevant question isn't when quantum decryption happens, it's whether you're using vulnerable encryption while your most valuable data is being stolen today. This brilliantly illustrates the core thesis of Vladimir Tsakanyan's research for the Center for Cyber Diplomacy and International Security. We absolutely must shift from just theoretically preparing for this to immediate, active cybersecurity planning. The old mindset just looked at this as a research issue, something we could kick down the road until hardware hits some specific milestone. The new mindset? It dictates that quantum readiness is a present-day, totally non-negotiable operational responsibility for our financial institutions. Okay, moving into Section 1, the interconnected web of finance, why a single bank upgrading isn't enough. So the reality here is that banks don't just operate like isolated, impenetrable vaults. They are part of this incredibly vast and honestly fragile web of dependencies. Think about it. A single financial institution connects to payment processors, clearing systems, cloud providers, and literally thousands of third-party software vendors. A cryptographic transition isn't going to succeed just because one bank decides to upgrade its own internal systems. If a bank is totally quantum ready on the inside, but it's exchanging information with a vendor that's still using a vulnerable protocol, the whole system is compromised. The security of the whole setup depends entirely on the ecosystem. Which brings us directly to how the government is responding. On August 24th, the U.S. Department of the Treasury announced the Quantum Readiness Task Force. This is a massive policy transition aimed squarely at addressing systemic financial resilience. Washington is officially done just asking when quantum computing is going to threaten us. Now they are figuring out exactly how a massive interconnected financial system actually migrates before that threat goes live. So the really crucial point here is that this public-private initiative breaks down this giant, sprawling problem into three very actionable work streams. First, you've got the more straightforward technical transition of core algorithms to post-quantum standards. Second, and we just touched on this, third-party and vendor readiness, because your security is literally only as strong as the software vendor you're buying from. And third, there is a super notable focus on digital assets. Decentralized systems are a totally unique threat because their cryptographic assumptions are baked right into the protocols and wallets, and there's no central authority to just force an upgrade. If a signature mechanism that protects ownership suddenly becomes vulnerable on a decentralized network, how fast can it even migrate? That's exactly what this task force is trying to figure out. All right, Section 2, mapping the cryptographic maze, the massive internal problem for institutions. If you're the person tasked with securing a major bank, you have to execute this massive strategic playbook. Step 1 sounds simple on paper, but in practice, it's a huge undertaking. Before you can replace any vulnerable cryptography, you actually have to know where it's hiding. And at the scale of a major bank, cryptographic functions are buried everywhere in hardware security modules, legacy infrastructure built like 30 years ago, network appliances, vendor APIs, you name it. Building a continuously updated cryptographic inventory is a monumental task. But once you have that map, you move to step 2, prioritize migration. You definitely don't update everything at once. You have to find where quantum vulnerability intersects with your highest financial and operational risks, and you migrate those high-consequence systems first. And that leads us perfectly into step 3, which really requires us to define this term, cryptographic agility. The goal here isn't just to install one brand new post-quantum algorithm, dust off your hands, and call it a day. Cybersecurity transitions almost never end permanently. Standards are always evolving, and new weaknesses are always being discovered. The big strategic lesson here is that governments and institutions have to stop building architectures where cryptography is permanent. We essentially need to build resilient systems that are designed from the ground up for constant, unavoidable change. Let's look at Section 3, regulating a global ecosystem, moving from technical solutions to geopolitical coordination. The June 2026 Federal Quantum Policy Framework definitely accelerated requirements across government systems. But the Treasury's task force, they're facing a completely different beast, translating national policy into real action across infrastructure that is operated almost entirely by the private sector. The government can draw up deadlines and give strategic direction all day long, but they rely completely on the operational knowledge, the tech providers, and the raw implementation capacity of the private sector to actually get this migration done. So this isn't just a technical working group, it's a live, high-stakes experiment in public-private security governance. And honestly, the friction just multiplies when you start looking across borders. The Treasury initiative builds off the G7 Cyber Expert Group roadmap, primarily because finance is inherently international. But this introduces massive G7-level cyber diplomatic hurdles. Different countries are going to move at completely different speeds. Vendors will update on different schedules. So what happens when a fully quantum-safe American financial system connects to a vulnerable international partner? It just inherits that risk right back through the connection. Payments have to cross borders. Markets depend on international counterparties. Trying to manage all these differences without totally fragmenting our global financial infrastructure is going to require intense, sustained diplomatic coordination. Finally, Section 4, the real race begins. The ultimate risk is coordination failure. So what you should really take away from all of this is perfectly summarized by Vladimir Tsakanyan right here. The weakest dependencies matter. The biggest obstacle to post-quantum security isn't the insanely complex math. It's not the hardware. It is literally systemic coordination. The right standards can exist, but if organizations drag their feet on adopting them, or if the giant banks migrate while their smaller counterparties are left exposed, the entire system remains at risk. A financial system doesn't suddenly become quantum safe just because its biggest, strongest institution finishes migrating. It only becomes safer as vulnerabilities across the entire ecosystem are progressively reduced. And I want to leave you with this final, really provocative thought from our source material today. This strategic race, it's no longer just about which country manages to build a powerful quantum computer first. There's a second, equally critical race happening right this very second. Which economies can actually replace their vulnerable cryptographic infrastructure before quantum capability makes that replacement completely unavoidable? Quantum security has officially moved out of the laboratory, it's moved into policy, and right now, it is moving into the infrastructure itself. The real migration has absolutely begun.